Alright guys, in the previous video we did the big three log expansion formulas. So remember that, by the way, this applies to any base other than base 10. I just figured I'd shorten the notation with just standard common log. So if you have multiplication inside of a logarithm, log of a times b, that's equal to log of a plus log of b. That's called the product sum rule. If you have a division problem inside of a logarithm, in this case log of a over b, that can be separated by expanding it into subtraction. So this is called the quotient difference rule. Log of a over b is equal to log of a minus log of b. And finally, the most important rule is the power factor rule. In other words, if there's an exponent inside of your logarithm, then that exponent flies to the front, becoming x log of a. So log of a to the x power the x can superman to the front and become x log of a. And I put an asterisk on there because at the end of the video I'm going to address why, to me, it's the most important rule. So in today's classwork, it's going to be a bit of a fun activity. I'm going to tell you to use your calculator, but not the actual log button. So remember those days when you just had a calculator with just these buttons, just the addition, subtraction, multiplication, division, maybe a square root here and there. But bear with me. We're going to be using our brain and the four orders of operations: addition, subtraction, multiplication, division, if need be. So for instance, let's say I give, wrong piece of paper. Let's say I give you only this piece of information. I tell you that log of 4 is about 0.602, okay? And I also tell you, let me put an end of the parentheses right there, that log of 12 is 1.079. Okay, let's say all I give you are those two pieces of information. Use the big three log expansion formulas to figure out what log of 48 is. Okay, so again, we're only using the information above this line, and we're gonna try to figure out what log of 48 is. So if we look at the big three, we're trying to figure out what log of 48 is. Well, if I have log of 4 and log of 12, and I want to figure out log of 48, I know that 4 times 12 is 48, so I'm going to use the idea of log of 4 times 12 to expand that into log of 4 plus log of 12, okay? So I'm going to cite my source. You guys remember in English class or social studies class where you have to cite your source in the paper, or do a bibliography at the end? It's kind of similar here. So I'm gonna cite my source on the right side in red. So basically what I did here is, since I know log of 4 and log of 12, I'm gonna convert log of 48 into 4 times 12. And I'm just gonna write it over here on the side just because I like to cite my source. 4 times 12 is equal to 48. And because I've got multiplication inside of this logarithm, I'm going to expand this by making this log of 4 plus log of 12. And the reason why I can do that is because there's multiplication on the inside. That is the product sum rule. Okay, well, do I know log of 4? Yes, above I do. So log of 4 is 0.602, and log of 12 is 1.079. And again, you could add these by hand. I'm just going to get lazy and use the calculator. So yeah, use the calculator, but don't use the calculator. So 0.602 plus 1.079. So that's 1.681. And just to check our work, now I'm going to use the log button. Log of 48 1.681, blah, 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 blah. We just use these approximations. What if I check my work by doing log of 4, close the parentheses, plus log of 12? Still, using the product sum rule, log of 4 plus log of 12 is equal to 1.68124, blah, 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 the same decimal. Okay, well now, we want to figure out what log of 3 is. Okay, if I know log of 4 and I know log of 12, how could I use the big 3 to solve for log of 3? I'm going to use the quotient difference rule because I know 12 and 4 can only result in 3 if I do division on the inside. So that becomes log of 3 by using log of 12 over 4, not log of 12 divided by log of 4, mind you. Log, and 3 is only accomplished by doing 12 divided by 4. Okay, all I did was say 3 is equal to 12 over 4. Okay, and then how do I expand 12 divided by 4 inside of the logarithm argument? Well, I can use the quotient difference rule. Log of 12 minus log of 4. If I have division inside of my logarithm, that creates subtraction expanded. Okay, so now I'm going to use what log of 12 and log of 4 are. Remember that log of 12 is 1.079. And log of 4 is 0.602. Okay, and now I'm going to use the subtraction part of the calculator to confirm. 1.079 minus 0.602. 0.477. And just to check my work, what is log of 3 in the calculator? There you go. I'm going to show off even more. Log of 12, close the parentheses, minus log of 4, close the parentheses. There you go. The quotient difference rule works. Division on the inside results in subtraction expanded. Okay, I only know log of 4 and log of 12. Well, what information gets me log of 16? Notice I did the problem twice. Well, 4 times 4 is 16. So I could write this problem as log of 4 times log of 4. Okay, well, if it's multiplication on the inside, it expands to form addition with their separate factors. So I can do log of 4 times 4 because 16 is equal to 4 times 4. Okay, good enough. And now I can expand this by going log of 4 plus log of 4. And that becomes the product sum rule. And now I'm going to look at the given information. Log of 4 is 0.602. And log of 4 is also 0.602. Okay. I could do this math in my head. Well, 2 plus 2 is 4. 0 plus 0 is 0. 6 plus 6 is 12, so that's going to be 1.204. But remember, I showed this problem in 2 ways. Not only can I get 16 from 4 times 4, I can also get 16 from 4 squared. Now, what does 4 squared do to the logarithm if there's an exponent inside? Yeah, that'd be 4 log of 4 squared. The exponent would factor out to the front, so that'd be 2 log of 4. So I rewrite this problem. Log of 4 squared, and the reason why I can do that is because 16 is equal to 4 squared. And because there's an exponent on the inside, I'm going to factor that out to the front. I'm going to put that in green just to show it lightly. That now becomes 2 log of 4 because of the power factor rule, or as one of my former students from a while back used to call it, the POW fact rule. Probably watched a lot of Adam West Batman or something, I don't know. Anyway, so we know that the 2 is factored out. So this becomes 2 times log of 4, which is 0.602. 2 times 2 is 4, 2 times 0 is 0, 2 times 6 is 12, so that's 1.204. And if you don't believe me, we can do log of 16 in the calculator. In fact, we can show it in 3 ways. Log of 16, log of 4 times 4, log of 4 plus log of 4, 2 log of 4. Same thing. I just want to show flexibility today. Okay, turn the page. Well, I know log of 4 and I know log of 12. How do you think I get log of 144? And again, I just showed it in 2 ways just because. Okay, let me just check really quick. Log of 12 is 1.079. 1.079, just so I don't forget. All right, well, remember that I can transfer this into 12 times 12, right? And the reason why is because 144 is equal to 12 times 12. Okay. And now that there's multiplication on the inside, I can expand multiplication on the inside with addition of their separate logarithms. So that's log of 12 plus log of 12. Okay. So that's 1.079 plus 1.079. Okay, I'm just going to get the calculator really quick. Clear, clear, clear. 1.079 plus 1.079. That'd be 2.158. Okay. Is there another way I could show this using other than the product sum rule? Oh, sorry, I forgot to set my source right there. Okay, by product sum, that's why I did what I did. Okay, well, remember that 144 is also 12 squared. So I can call this log of 12 squared. And remember that because 144 is equal to 12 squared, well, now I've got an exponent inside of my logarithm. Using the power factor rule, log of 12 squared, that exponent comes out to the front, leaving me with 2 log of 12. So I bring this out to the front. 2 log of 12, because of the power factor rule, or POW fact. Now I just do 2 times 1.079. Okay, pull out the calculator. 2 times 1.079 is also 2.158. And just to make sure, I can do log of 144. Pretty close. Okay. All right, see if you can do these 3 problems independently. Log of 1/3, log of 1/4, and log of 1/12 if the only pieces of information I'm giving you are log of 4 and log of 12. See if we can do these 2 problems independently. Okay, So let's take a look at log of 1/3. If all I'm given is log of 4 and log of 12, well, you just need to remember that 4/12 is 1/3. And now, I still got a division problem, but at least I know what log of 4 and log of 12 are. I just made a little note to myself. Okay, well, since we've got division on the inside, the division on the inside rule is the quotient difference rule. Log of 4/12 can be expanded by the log of 4 minus the log of 12. So let's do that. Okay, and this is called the quotient difference rule. Now that I know I've got log of 4 minus log of 12, I'm going to plug in the given information. Remember that log of 4 is 0.602, and log of 12 is 1.079. I'm going to plug that into the calculator. 0.602 minus 1.079 is negative 0.477. And just to check our work, log of 1/3, negative 0.477, blah, 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 blah. Okay. All right, number 6, log of 1/4. Okay. Well, log of 4, log of 12. Well, oh, I take it back. It just dawned on me. Remember that I know that log of 1, sorry, this is log of 1 over 4. I'm given 4, and I'll show you something. I can expand this by making this log of 1 minus log of 4. Well, truth is, even though it's not given to us, we actually do know what log of 1 is. We know this is the quotient difference rule. If there is no base, what is the base automatically? 10. It's basically saying 10 to what power is 1? 10 to the 0 power is 1. So log of 1 is 1. Minus log of 4. Okay. Log of 4 is 0.602. So therefore, yeah, there we go. We get negative 0.602. And just to check our work, I'm going to use the calculator. Log, clear. Log of 1/4 would be negative 0.602, blah, 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 blah. Okay. And finally over here, log of 1/12. Well, if we know log of 4 and know log of 12, and guess what? We kind of already knew log of 1. We can expand this by making this log of 1 minus log of 12 by the quotient difference rule. Just like social studies class. We support our information with evidence. Well, log of 1, 10 to what power is 1? That'd be 0. And log of 12 is 1.079. And finally, that means that log of 1/12 is negative 1.079 approximately. So if I plug that into the calculator, just to check my work, log of 1/12, negative 1.079. Okay, well that was a fun exercise. Even though it's not going to be on the test, it's going to strengthen our knowledge for what's coming up next. Well, I'm going to fulfill my promise. Why did I say that the power factor rule, aka log of a to the x is equal to x log of a? Why did I say that that was the most important rule? Well, remember that I said that the human can do this faster than the calculator. You go 2 to the first is 8, 2 squared is I just went there. Someone was like, "What? 2 to the first is 2. 2 squared is 4. 2 to the third is 8. Haha, we have a winner." So that's how we do this as a human. We go x is equal to 3 because 2 to the third is equal to 8. Okay, but your calculator doesn't know how to do that. Instead, it's like it has to use the change of base theorem. I'm putting it in quotes because that, I mean, not because I'm making up a theorem, but that's really what it's called. In other words, your graphing calculator, this TI-84, doesn't understand base 2. But if you trick it, you make it do a little magic trick. You go x is equal to log of 8 over log of 2, and then just magically, at a snap of a fingers, you get 3. Well, now I'm going to show you what it is you're doing, okay? So why is it that if I use this little magic trick every single time, that's how it works? Well, here's what you're doing. Well, recall that if this was, I'm just going to make this up on the side, if this was x plus 2 equals 8, you would subtract 2 from both sides. If this was 2x equals 8, you would divide by 2 on both sides. If this was, let's just say, x squared equals 8, then you would square root both sides. In other words, there's a whole bunch of inverses that you can apply. Did you know that you could log both sides? Yeah. So in other words, I've got 2 to the x is equal to 8, right? What I'm technically doing is I'm applying log to both sides. Literally, I apply log to both sides. That is algebraically legal. So log of 8, I have no idea what log of 8 is. Okay? However, I've got an exponent in my logarithm, and that annoys me. So what that does is that makes this x fly to the front. X log of 2. And the reason why this works is because of the power factor rule. So now I've got x log of 2 is equal to log of 8, and I want to solve for x. So I'm literally dividing both sides by log of 2 to get x isolated. It's not a magic trick, it's just algebra, sorry. I'm not a magician, I just know algebra. So I've got log of 8 divided by log of 2, and then in the calculator, change of base theorem, that becomes 3. But no, seriously, it's not a magic trick anymore once I show you that it's literally the power factor rule applied. Okay? Hope you guys enjoyed this video.